So, welcome back. As we were discussing about the tsunamis, and so if we come back to the and look at the overall scenario of the Indian plate, then what we have the seismic zones. We have like Himalaya, which we have already discussed in when we were talking about the active faults and all that. Along with that, we have almost like more than 7,500 kilometers long shoreline, which is vulnerable to the tsunamis and the earthquakes triggered by subduction zone. So, one subduction zone we have over here and another one is over here. Okay. So, other than that, we have like earthquakes taking place in Kutch, and based on that, what we see is that we have the high risk zone and sitting in zone 5 is Andaman, which is because of the subduction zone we have here, and high seismic zone, that is Sumatra Andaman subduction zone. And we have few historical events which have been documented in historical chronicles. And other than that, we have another subduction zone which is going to affect the Indian coast along the west side, that is your Gujarat as well as the west coastal mainland India, is your Makran subduction zone, which also talks about that there was 2 tsunamis in 325 BC, another one in 1945. So, with this, if you look at then what we observed and experienced in 2004 earthquake of 9.3 or 9.1, that is Andaman Sumatra Andaman earthquake. These are all red bars which shows the wave heights which were been recorded. So, this bar is 10 meter high. Okay, so you can understand that what is the height here. Now, the point is that if we compare the rupture length and compare the 3 major or the mega earthquakes so far recorded, like we had 1960 the Chilean earthquake 9.5 magnitude, and Tohoku at around 9, and 9.3 or 9.1 Sumatra Andaman 2004. So, the rupture length here was almost like 1000 kilometers or so, but in the case of Tohoku, though it was very damaging, the rupture length was almost half of what we see here. In both, this was almost like 1300 kilometers, this was 1000 kilometers. This Chilean earthquake 1960. So, this whole area is vulnerable from the tsunamis as well as this zone, and then what we have over here, that is your Makran subduction zone. In India, after 2004 tsunami, Ministry of Earth Science, they came up with the institution or organization known as INCOIS, Indian National Center for Ocean Information Services, which now gives the information, that is early warning if we have a tsunami, not only from the Andaman subduction zone or Sumatra Andaman subduction zone, but even from if the tsunami is triggered from Sumatra area. So, this is an excellent initiative by the Ministry of Earth Science to set up the organization in INCOIS, which is going to definitely safeguard all of us from by issuing the early warning of any such events. These are the locations of where we have the what we call the deep ocean assessment reporting tsunamis, that is DAD or BOI system. You have, these are the locations of those which will take into consideration the wave heights and all that, and they will transmit through the satellite, and that will be collected and in particular organization which will issue the warnings. So, tsunami warning system, how it works is that you have the seismic observations as well as the sea level observations, which have been taken into consideration by the installment of the gauges or the buoys, and then with the help of that you issue the tsunami warning to the local agencies and the areas which are vulnerable to the tsunamis. Then the local this is extremely important because the lot of area has been occupied by the people along the coast. So, the coastal community should be informed, and then you should have a proper evacuation plan. Other than that, you need to have the proper tsunami hazard maps for mitigation purpose, and also the tsunami signs, okay, which shows that which location you need to move on the high grounds to protect yourself. And also the in some countries, and even now we have started in our own country, that we have the education and awareness through the booklets and the native languages in Hindi or maybe in different languages depending on which the state is touching the coastline. And then we have the small videos which with the cartoons, which helps the local residents. So, this was the photograph which we took after the 2004 Sumatra Andaman earthquake, and the team which was was from IIT Kanpur, and 2 of our students who were in army have also joined us for the for this survey. So, I will just quickly browse through that what signatures of the tsunami damage we observed after the 2004 Sumatra Andaman earthquake. Okay. So, as we know that our seismic zonation map, that Andaman sits in zone 5, is highly vulnerable zone because of large magnitude earthquakes experienced in the past and having a very active subduction zone which sits here. So, one of the ideal location to experience or have tsunamis from this region. So, this is the subduction zone in which I am talking about. Sumatra, either you call this as an Sunda Trench or Sumatra Andaman subduction zone. So, the location of the chain of islands of Andaman and Nicobar. So, this is the southernmost tip. So, I will show you what we collected the information moving from this that is south, then we move towards north. And so, not only we are able to see the signature of land level change in terms of subsidence, but we also looked at the uplift which was been experienced along the west coast of Andaman and subsidence in the east coast of Andaman. And this locations we found a massive subsidence which ranges up to 3 meters somewhere over here. That is the tip of the southernmost tip of the Andaman and Nicobar Islands, and this location marks the Andaman Trench area. So, 1300 kilometer was the rupture. It started from here. It went right up to the tip of the northern tip of the Andaman Island. So, major events during recent past, if you get into the literature, then you will find 1679, then 1762 was around Arakan. So, Arakan is sitting somewhere over on the top of this over here. This is an Arakan zone. So, this portion is also quite vulnerable to trigger the tsunamis, and which will affect, of course, the areas which are sitting along the coastline and also the regions which are sitting touching the Indian Ocean. Okay. So, areas along the Indian Ocean are vulnerable to tsunamis not only from the Sumatra Trench, but also from Sumatra Arakan Trench. So, these are few earthquakes which are been listed, or we have the records from the historical literature, but most of these earthquakes are 7.5. So, what we have been able to emphasize in our recent research that we should not ignore such large magnitude earthquakes also. Okay. So, we have these earthquakes from there, okay. And then some indications of the land level change was been given, that was in 1881, okay. That was in Makran, that around 50 centimeter uplift was been recorded. Now, this region is, as I told, that is one of the ideal region to trigger the mega earthquakes as well as large magnitude earthquakes as well as associated tsunamis. Okay. Now, as this already I had discussed, that we measured the areas in terms of the subsidence and the uplift, and that what I would like to present here. So, we have the co-seismic land level changes along Andaman and Nicobar caused by 2004 Sumatra Andaman earthquake. So, the blue letters or the number shows your subsidence, and the reds are indicating the uplift. So, in particularly the Andaman Island, which is one of the largest one in the chain of Andaman Nicobar Island. This was the zero line, that is pivot line, which did not experience any land level change, but so it was just in sort of an axis here. This got uplifted and this got subsided. Literature also talks about that the local tribes, they have a very good understanding of the tsunamis, and usually that is reflected in their the construction of their houses. Okay. So, they usually have the houses sitting much high at higher level from the ground, where this the water comes in and goes back, but they are not disturbed. So, they will climb up and then they will sit on the upper floor where they have the main house. So, this understanding they have better than the present local people staying there. Okay. So, this was been generated by a model by Professor Kenji Satake from Earthquake Research Institute, University of Tokyo, and if you carefully watch this, then you will be able to see that this is the time which has been given here, and then whole front ruptured, and this was the source for the tsunami, 1300 kilometers, and it took almost like more than an hour to reach the Indian, that is the east coast of mainland India. So, I will just play this again, and then you can see that almost it took more than an hour, almost 2 hours to reach the Indian coast. So, if we had an understanding of such tsunamis, then we could have evacuated people along the east coast where major devastation took place. So, now looking at the subsidence and uplift, okay, in this region of Andaman. What we found was that we started from the Great Nicobar, that is the Indira Point, the southernmost tip of the Andaman. We observed the subsidence of around 3 meters, and this photograph, which was been provided to us by Coast Guard, which shows the beach here, and then you have some huts or the houses here and the watchtower. And the next photograph, you can see that the huts have been completely wiped off, and the beach have started forming farther inland as compared to what it used to have somewhere here in the previous photograph. Okay. So, this suggests that the area subsided, and the area subsidence was almost around 3 meters here, and this was the case in that region. The coastal regions were subsided and all that. And this were the photographs which the area we surveyed from the Coast Guard office in Campbell Bay, that is Great Nicobar, where they told that informed us that the beach used to be almost like 50 meters from this part, but now the area is getting inundated even during the low tide. So, this clearly indicate that there was a subsidence in this area, now water getting in even during the low tide. This was the case or impact of the tsunami waves inland. And then we heard a story on our way to the Andaman Nicobar that the Trinket Island got splitted in two islands, and then we had a chance to fly over it, and then what we identified was that was merely because of the subsidence and the low lying area and between the two islands where the water spilled over because of the during the tsunami wave, and even after the area was getting inundated. So, this is the photograph of the Kamrut Island before we get into this one. This is the portion here. So, we were flying at this location and we found some signature of drowned beach also. So, drowned shorelines along the Kamrut Island, you can see here. This is the drowned shoreline, and this one which subsided during 2004. And then splitting of the islands, if we this what was been taken by the Indian satellite, which shows that this portion was it looks like that they got splitted in two, but this is because of the subsidence, the area subsided and the low lying areas were being inundated. So, this were the photograph which we took, aerial photographs, which shows the inundation part in the central portion of the Trinket Island. Now, coming to the Car Nicobar here, the subsidence was almost like 1.5 meter or so. Now, the island is extremely beautiful, and the height is not much in terms of the elevation. The hills are not very high and very flat topography here, wonderful beach, and this whole area is been occupied. That is, this is towards the eastern coast. This whole area has been occupied by the Indian Air Force residential colony, and we have the airstrip also over here. So, this is what you see here. This is the airstrip, and this whole area is having a wonderful beach and the residential area, but this whole portion was affected by the tsunami and devastated the region, and this area got subsided by almost like 1 to 1.5 meter or 2 meters at some places. So, few structures survived, like the water tank here, because of its the structural pattern, circular in shape. So, the energy got disseminated here, and this got survived, but most of the houses were been swept off, one because of the earthquake, ground shaking, and then because of the tsunami. So, the giant trees were been uprooted, and when we spoke to the survivors, Captain Manohan, he told us that the shaking was at around 6:35 a.m. and after 15 to 30 minutes later, the first wave arrived with the wave height of around 1 meter. But then we realized that this was the inundation was just because of the subsidence, because the area subsided during an earthquake and the water inundated the region. Okay. So, the second wave was higher, and then that what he told, but that the second wave was actually the tsunami wave. And then the third wave was much higher, which was marked by the height almost like 8 to 10 meters, and this we were able to observe or record from the signatures of the water level and the cloths and the debris which were sitting on the windows of the first floor. So, it carried and deposited sand in this area, and also the coarser coral fragments. You can see here the dead fish lying on the floor of beach, and this photograph which I was showing earlier. So, this used to have almost 100 meter wide beach here, but now this sits, and this is an inspection bungalow. So, they used to have meetings here and parties here, but now this sits in water. Should not have been the ideal place. No one will construct the the inspection bungalow or a residential bungalow sitting in water. So the subsidence was almost like around 1 to 1.2 meters in this region, and this is the feature which I have already discussed. Now what we have, the formation of beach ridge, and this photograph was taken in 2009-10 after the. So the environment get changed because of the subsidence, and in some locations the environment got changed because of the uplift. So if you look at this window here of the first floor and the top tin shed, then you can easily make out that the wave height would have remained up to this, which blown off the top of this apartment, and the windows shows the cloths which are hanging here at the top. Okay. So height was almost like we can make out that it was more than 7 meters. Second markers we found was the inundation watermarks here in most of the houses, and the height was almost like 3.5 meter here from ground. Okay. What happened was the first wave, when it came in of 1 meter, then people moved on the first floor thinking that this is because of the inundation, but the tsunami wave was much higher than this one, and it wiped most of the people here, and some of them they ran on the high grounds and they survived. So this is because of the return wave which went back, and the airport was also full of the debris, and even you can see the television here, and the water tanks, not water tanks, these are all oil tanks which were quite heavy but were been transported by the tsunami waves way inland from the coast. Okay. Now another, this is Hut Bay. So we are slowly moving from south to north. It was extensive damage was experienced in this region also, and again similar features of bending of the fan wings because of the return wave, and most of the walls were been broken. So you can understand that amount of energy in this area because of the tsunami. And then we also looked at the signatures of the waves which came in, multiple waves. So you can judge the height of different waves from this. So one wave is around 1.5 meter from this floor. Okay. So if you calculate from the mean sea level, then it will be much higher than this one. Okay. Then second one is around 2 meters or so from the floor of the house. Okay. And then coming to another one here, what we found, the uplift and the subsidence on the east coast and the uplift on the west coast. So I'll just quickly show you some aerial photographs and the ground photographs from this region. Okay. So we took help of the Coast Guard, and we flew in the helicopter, as well as we also used a small airplane to conduct the survey. So this is what we found along the west coast. So this was before and this is after. So the area got uplifted here and got exposed. And coming to this portion here, that is the Sentinel Island. No one tries to go here because this whole island has been occupied by the tribes, local tribes, and the photographs which were been provided to us were from Coast Guard. So what we found here is that there are many coral platforms, okay, or the terraces which are indicative of past uplift during major earthquakes. So Sentinel Islands, no one tried to go, and this photograph again was been taken by Coast Guard, the local tribe holding in bow and almost like 2 meters and trying to aim the helicopter here. Then coming to this portion, that is your Port Blair and Sippigat. The Port Blair area and the Sippigat area close to that subsided during. So this falls on the east coast of Andaman Island, and the subsidence was almost around 1 meter. And this area was famous for its yield for paddy, and how the settlement So, now nobody is interested in buying houses here, because the area is getting inundated because of the subsidence in the region. So, this is the scenario now. So, if you look at this one here, so this whole plantation now sits in water, and then local administration, they understood that this is not the temporary solution or the temporary inundation. For initially they thought of that the tsunami wave came in and got inundated the area, but now they later on they realized that this is the permanent thing which is going to happen. So, they raised the road heights to provide the proper transport to local people. So, this is what it's been shown here. So, this was been raised by almost 1.5 to 2 meters. So, subsidence was observed at different other places also along the east coast. Now, past earthquake signatures and sediment succession, usually we try to look for that. So, the earthquake occurs when this we have already discussed. So, we will just move ahead. So, keeping this in mind, we started hunting for tsunamis preserved in sediment sections around Badabalu. This is one of the best signatures, the location where we found the signatures of at least 7 tsunamis from southeast coast of Andaman. So, Badabalu is a wonderful beach located south of Port Blair, where not many people visit, but now people have started visiting it after the event. So, if we consider this, and then that if you have a soil, and then earlier you had in the vegetation here, and during subsidence the land level went down, and this whole area started getting inundated, and because of the increase in salinity because of the inundation of the ocean water, this will die. And so, we will see some remnants of the trunks of the trees, and or we can say the dead forest. So, this is because of the inundation, and further we have the deposition coming in, and then new surface evolves here. So, if you look at this signature, how it looks like, this is from Willapa Bay from US, which shows the preservation of the trunk of the tree which died because of the subsidence in this region. Okay. So, such examples or the signatures we try to look at, if possible, if they are preserved, if they remain preserved in the sediment succession. Another part is that we look at if we see the sediments getting preserved, which were been brought or transported during the tsunami. Okay. So, this part which we were talking about in the previous one of the previous slide, that if you are having the marshy area and then it gets subside, then the sediments which were been brought or transported during the tsunami will get preserved. And when you dig this section, you will be able to see the deposits, that is your sand sheets. Okay. Most of the areas before we start hunting for the tsunami, we try to look at the areas which are having and topography, which is shown here, like we have the beach ridge, and then we have swell, beach ridge swell. So, most of the time what happens that if you have a tsunami, then this portion or the sediments from this will get eroded. Of course, the tsunami will also carry the sediments from the deeper portion of the ocean, and along with that it will also carry the organisms. Okay. So, the fossils which we find in the deposits are also a good indicator of the sediments were been deposited by tsunami, because otherwise in case of the storm also, the storm can carry the sediments and deposit along the coastline. So, to differentiate that, we use one of the proxy like the paleontological studies of microfossils and mainly foraminifer we use to understand, because they grow or they live at the deeper ocean depths. Okay. So, that helps, and then since we have we see the depression here, so most of the sediments which are eroded from this one will get deposited in this area. So, we were lucky enough to look at the previous images that we from different time before 2004 and then after 2004, and then we were able to pick up from Badabalu that how the landscape got affected because of the subsidence and the wave action from the tsunami which was triggered by 2004 Sumatra Andaman earthquake. And this is the comparison here. So, because of the subsidence, so before that the beach used to be here, which is marked in yellow, but after subsidence it inundated. So, the whole area over here was affected because of the subsidence, and then what we found was that the back marsh behind the beach ridge used to be here, but now it is seen further inland. So, if there is a change in the environment in past events also, we can be able to pick up this. So, we also found some dead trees and dead forest and uprooted trees due to subsidence and due to the massive erosion by 2004 tsunami, and these are all indication of that. So, beach used to be here, but now the beach and the beach has moved towards land. Okay. So, local people have artificially filled the area to protect the inundation and safeguard their agricultural filters. So, this is what it shows, that the landfill was almost like 1 meter they did in this area. So, location of the Geo Slices, we took these sections from this area. We also open up small pits, and then we also took the topographic profile to mark that how much amount of land level change has taken place in or took place along this because of 2004 earthquake. So, we used pits, and then if you carefully see this part here, this is the 2004 tsunami sand preserved in the sediment section. So, these are the trench photographs which were been taken from the area around Badabalu. So, we based on the grain size, the color and the contact, we demarcated the units. So, these are the different units which we marked, these of sediment layers, and we also collected samples of sand and charcoal to be dated, which helps us in bracketing the events. And this was the Geo Slice, Geo Slicer which we used to take the section up to 3 meters. So, this is connected with the generator here, and then we are putting inside the surface, and finally collecting the section here. So, a lot of hard work, and then finally what we see is the section coming in, and then we also peel up this and preserve in our lab to have the library of the sections. So, this is how it looks like, and this is 2004 here, and this was the previous soil of 2004, and now the tsunami sand sets here. This we are doing total station studies, took the topography profile, and then detail logging, and then in lab we also did particle size, the grain size analysis, and most of the tsunami shows bidistribution, bimodal distribution, because they are not well sorted. They show the mixing of the different grain size. Okay. And we also took help from the paleontological studies. Mainly we did micro fossils, okay, in lab, and these are the microfossils which helped us in justifying that the sediments were being carried from the deeper part of the ocean and deposited along the coast. So, if you look at the close up of this, then what we see here is the blackish layer, that is your peat, and on the top of this we see the tsunami sand. And tsunami sand also, the deposits also are not very well sorted. They are poorly sorted and shows the inclination or the inclined stratification, sharp contact with the underlying units and all that. So, those things we took into consideration to identify the tsunami deposits from the normal storm deposits. Okay. again the very sharp contact here and the very thin sediment layer here of medium sand. And one thing which you should remember is that the grain size of the tsunami sand will reduces. So, you will have the coarser material near the coast, and if you move further inland, then it will become finer. So, this will be near the coast, it will have coarser and thicker, and inland it will become finer and thinner. So, this is we are talking about the thickness. Okay. So, it will be we will see a thicker section here. So, this is close to the coast. So, we see coarser and thicker, and as we move inland, then we found that they are becoming thinner. So, the sediments will pinch out because the carrying capacity or the energy condition changes. Okay. So, these are few more examples, and based on this what we did was we collected the different samples from different units, and we tried to bracket it and interpreted our whole sections, okay, and in terms of the tsunami events. So, all yellow, this diagram in yellow color shows the tsunami sand, and we put the so this is the importance of the topographic profile which we took, and then we also looked at that what was the low level tide and mean sea level and high tide levels. Okay. And based on this, we identified that the area subsided by around 45 to 50 centimeters in this area. Now, with the ages which you see here, we used charcoal and did the AMS ages as well as OSL dating we did of quartz grain, that is from sand, and that helped us in bracketing the events, and based on that we were able to identify the 7 tsunamis here. Okay. So, this is how we can reconstruct the history of tsunamis and the mega earthquakes, because whether we have the tsunami deposited by the mega earthquakes or large earthquake, that also can be differentiated based on the thickness as well as the sediment size. That can help us, and then we can also talk about the recurrence. So, what we found that from our present study as well as the previous one, that there were at least 3 mega earthquakes from this region which were responsible for triggering large magnitude like large magnitude tsunamis. Okay. And the interval was around 420 to 750 years for the mega earthquakes and giant tsunamis, and the large earthquakes which were triggered in between. For example, if you look at, so those were the large earthquakes which were triggered, and for example 1762 and then 1881 and so, and this one also was the large earthquake, that is in 1679. So, those earthquakes were the large earthquakes in between within shorter interval of around 80 to 100 years. Okay. So, with this I end my lecture here, and thank you so much for your attention. Best luck.